Multiplying vectors, the dot product. Earlier, in a separate video, we talked about adding two vectors together. For example, the vector 3, 2 plus the vector -1, 5 says that we simply add the like components. That is, if I consider the first part the x, I can just add the x's together, 3 plus -1. And the second part is the y's, then I can add the y's together, 2 plus 5, and just leave the comma in between them, giving us the vector 2, 7. Similarly, we multiplied vectors by constants. So if I had the vector 4 times 3, 2, I simply multiply the 4 by each component individually, giving me the vector 12, 8. Now, what if we wanted to multiply two vectors together? So let's go ahead and multiply the vector 3, 2 times the vector -1, 5. There are actually different ways of multiplying vectors. The two most common are called the dot product and the cross product. In this case, I'm going to do something called the dot product, which is why I put a dot between the two vectors. And although multiplying vectors is a little bit more complicated than adding them, the math behind it is very simple. Let me start by putting what it is not. When we're multiplying two vectors with a dot product, we don't simply multiply the like components. That is not correct. Do not do that when you're doing the dot product. The dot product instead is a combination of multiplication and addition. Once you get used to it, you'll see it's pretty straightforward. The math is not difficult. But you just have to know that it is slightly more complicated than simply multiplying like things together. So what do I mean by a combination of multiplication and addition? Well, I do, in a dot product, multiply like components together. So I would multiply the x times the x, 3 times -1. And I would multiply the y times the y, 2 times 5. But instead of having a comma between them, I add these two values together, giving me -3 plus 10, or 7. So when we do the dot product of vectors, we don't end up with a vector. We end up instead with what is called a scalar, or simply a number. Let's do a couple more examples. Let's do the dot product of 2, 3, 4 with 5, 6, 7. In this case, I think of this as x, y, and z. So I'll multiply the x's together, 2 times 5. The y's together, 3 times 6. The z's together, 4 times 7. And I add the values. 10 plus 18 plus 28, which gives me the dot product is the value 56. One more example with a little bit different notation. We'll do vector notation, but as matrices, so you get used to matrix multiplication. And when we multiply vectors in matrix notation, we usually write one as a row vector and then a column vector for the second one. But still think of the first thing in each part being the x's, so the 2 is the x in the first one, the 5 is the x in the other one, we multiply them. And then the y is the second part in each one. So negative 2 times 3 would be my dot product. And then I add these things together. 10 plus negative 6 equals 4. So it's a multiplication of a row by a column. But it's still doing a dot product. And we'll see that very soon when we do a video on matrix multiplication.